If you remember Loki from the Avenger movies, you might even be familiar with the space stone which is contained inside the Tesseract. The space stone opens up a gateway which can take us to any place in the universe, which the name itself does suggest, but we're not exactly told how it allows you to teleport. Maybe by creating wormholes which can bend space? So the space stone is very powerful, capable of meddling with the fabric of space in 3 dimensions. It's not possible to store something like that in a shiny blue box, so definitely the Tesseract is not an ordinary container. Maybe the Tesseract is something of a higher dimension, somehow in 3D space, capable of containing a stone which disrupts space, which may also be an object of a higher dimension. Just like, say, to fold a 2D paper, we need a 3D hand. We need something 4 dimensional to bend 3D space. And the word tesseract does mean a 4 dimensional hypercube, that is a cube of the 4th dimension. But 4 dimensions? A 4 dimensional cube? What does that even mean? To wrap our minds around the concept of 4 spatial dimensions, we will start from the bottom of the ladder at the 0th dimension, which is also called the point dimension. The point dimension is a single point which is dimensionless. It has no length, breadth, or height. The 0 dimension is not actually spherical, but this is just a way of representing it. The first dimension is formed by extending the point dimension in any direction. Further extruding the line dimension in a direction perpendicular to it brings you to the second dimension. It's in this dimension that geometry starts to get more complex. The square from the second dimension now gets extruded in a third perpendicular direction to form a cube which has a length, breadth, and height. Notice that the cube you see here is actually the depiction of a 3D cube on a 2D screen. However, we're able to comprehend it as we're accustomed to 3 spatial dimensions. Now imagine if we take this one step forward and extend the 3-dimensional cube in a 4th perpendicular direction. We get a hypercube having 16 vertices, 24 squares, 32 edges, made up of 8 cubes arranged at right angles. This is a depiction of a hypercube in 3D space portrayed on a 2D screen. We cannot see how it would actually appear as our brains are not trained to see anything beyond the 3 dimensions. With this in mind, in 1884, Edwin Abbott published his bestseller Flatland, which depicts the problem of not being able to see or comprehend higher dimensions. He describes the life of shapes living in a 2D world incapable of perceiving 3 spatial dimensions. He explains that how in Flatland all shapes appear to each other as straight lines and distinguish each other with the help of brightness. Here's an example of how a hexagon would look to, like, say, a circle. Now if you compare this to a triangle, we would get something like this. The varying brightness of different shapes allows them to see and recognize each other. In the case of the triangle, the middle point would be very bright because it's the nearest, but on either sides the line would shade away rapidly into the dimness. However, in the case of the hexagon, there's a bright center which shades away less rapidly. Now imagine if we take this 2D plane and pass a sphere through this 2-dimensional world. 2-dimensional beings unable to perceive 3D objects would see something like this. A circle increasing in size until the sphere reaches its center, after which the circle goes on shrinking. Now similarly, if we passed a hypersphere extending in 4 spatial dimensions through our 3D world, we would see a sphere increasing and then decreasing in size. This is because the hypersphere has an extra dimension as compared to the world we live in. That's just so astounding, to even think that we can walk in a direction that we've never gone in, taking a path that is impossible to take in the limit of 3-dimensional space we are known to. Try now going left or right, north or south, up or down, but traveling in a completely different manner, not measuring height, width or breadth, but strength. Now along with these spatial dimensions exist time dimensions. So the 4th dimension basically comprises of 4 perpendicular space dimensions and 1 time dimension. Even though some people say that the 4th dimension is a time dimension, there may even exist a universe with 2 time dimensions instead of 1. And now if you were to think of something, at the end of Flatland, the sphere lifts the square off his planar world into the world of 3 dimensions. Now what the square saw was quite intriguing. He saw his two-dimensional world but from 3D space. He could now aptly see his fellow Flatlanders but from a more clearer perspective. Back in Flatland, even though it was a 2D world, they had but a one-dimensional view and would perceive depth, or in that case width, with the help of brightness. Similarly, even though we are 3D creatures living in a 3D world, our eyes can only show us two dimensions. That's because your eyes are separated on your face and each retina produces a slightly different image. That difference in image allows us to perceive depth of objects that we are looking at. So, if we were ever to go to a four-dimensional world, we would be able to see ourselves from a completely different angle, in a completely different manner, a more clearer perspective. Just like the square who for the first time actually saw the sides of the hexagon.